everyone, welcome to the session. My name is Abhishek and I'm mathematics faculty here at askIITians. And this is lecture number 2 of the chapter Exponents and Powers. And before we start or before we discuss the topics that we are going to cover in this particular lecture, it is very important to revisit the weightage of this particular topic as far as your as far as your school examination is concerned and your competitive examination is concerned. So if I talk about school examination, then the weightage of this particular chapter is 6 marks. Okay, that means you can expect questions, 2 to 3 questions from this particular chapter in your school examination. And if I talk about Olympiad weightage, when I say Olympiad, that means I'm talking about IMO that is conducted by NSO or NSTSC, right? Then in that you can expect around 2 to 3 questions from this particular topic. But this topic is very important because of the reason that the properties which we studied in this particular chapter in the last session and the things that we are going to study in this session as well, we use them very frequently in a number of other topics. Okay, like you will be using them a lot in your senior classes. So it's very important to study this chapter properly and understand each and everything that we have in this chapter to have a good command over the upcoming topics that you might see in your senior classes. All right, so before we start this, let us see the topics that we are going to cover in this particular session. So we are going to cover 4 topics in this particular session. All right. The first topic is writing very small and very large number in the form of exponent. Okay, that is our first topic. The second is how to express large number in the standard form. We will discuss what is the standard of the scientific form that we have to express large numbers. So we will discuss each and every case that we have in that. After that, you have this topic in which we are going to learn how you can compare the large and the small numbers, which is very easy, believe me. And at last, you have fractional powers. What happens when the powers which you have of the base of the terms that are present in base, they are fraction? Then how to proceed, how to solve that? That's what we are going to discuss. So if I have to tell you broadly, guys, here all the topics that we have studied or we are going to study, they all are super easy. It's just that you have to be a little attentive while we discuss them. And believe me, if you will remain attentive while we are discussing this particular session, you will get the command over all of them very easily. Right? So shall we start discussing our topic number 1? Okay. Okay, so we have like, let's say you have to write. We have few cases, guys. Okay, here what we are provided, you have to write the numbers which are given here in the scientific notation. So first we need to understand what is the meaning of scientific notation, what are the different cases we have, and how to actually do it. And that is not a difficult thing, that's a very easy thing. Okay, so how can we do it? Let's say I'm taking case first for A. Okay, case first, that is A. All right, in A, what I am provided 2400. All right, 2400. Can we write this 2400 as 2400.0? We can of course do that, right? Because if you have a number, let's say 5, you can always write that number 5 as 5.0. You can write 6 as 6.0, 12 as 12.0, etc, etc. Okay, now writing this number in the scientific form means you have to move this decimal in such a way that there is only one digit on the left hand side of the decimal and rest of the digits should be on the right hand side of the decimal. Let me repeat once again what I have said. I am saying if you have to write or if you are planning to write this number, which is 2400 in the scientific notation, what does that mean? That means you have to move this decimal, which you can see like here in this number, we have 2400.0. So this decimal needs to be moved in such a way that there is only one digit on the left hand side of the decimal and rest of the digit should be on the right hand side of the decimal. That's what you have to do. Correct or not? So here what I have to do, I have to move this decimal by how many places? One place, two place, three place. Okay, then only this decimal will come here. So because I have to move this decimal by three places, so can we write it as 2.4 into 10 raised to the power 3? Why 3? Why 3? This 3 that we got, it is the number of places the decimal has been moved on the left hand side. Is that clear? I'm writing here. That means the number of places the decimal has been moved. The decimal has been moved, okay, to the left side. To the left side. So since in this very first case that we have, we moved this decimal by how many like how many places? Three places. One place, second place, three places. When we move this decimal to the left hand side by three places, we got 2.4. And since we have moved it by three places, you need to write it as 210 raised to the power 3. And believe me, this value which we got is exactly same as what was given to us in our question. For example, if I simplify it, what will I get? I have 2.4 into 10 raised to the power 3. So 2.4 can be written as 24 upon 10, because if you remove decimal, you are going to have 10 in the denominator. And this is 10 raised to the power 3, which can be written as 1000, right? This 0 and 0 will get cancelled. And when 24 is multiplied to 100, we all know what are we going to get. We all are going to get 2400, which is exactly same as what was provided to us in the problem. So this form that we have got here, that's a scientific notation or the scientific form, you can say, or the standard form. Is that clear? Is that clear to everyone what we have to do whenever we have whenever we have to convert any number into the standard into the scientific form? Like this is only the one case I have taken where I was having 2400, like I was provided a proper number. But we are going to discuss other cases as well, like B case, C case, which is written different, D case, which is again very different from the rest of the cases. So those cases also we are going to discuss so that you have more clarity over this particular concept. All right. So this was case one. One second. Here, I'm going to discuss case two. Okay. And you guys will be helping me out with that. In case two, what is the number you have? The number you have is 72000, right? Can we write this number 7200 by 720000.0? We can write it like this. And we have to move this decimal to the left hand side in such a way that there is only one digit on the left hand side of the decimal and rest of the digit must be on the right hand side of the decimal. So by how many places do we need to move this decimal on the left hand side? So one place, two place, three place, four place, five place. I am repeating again: one place, two place, three place, four place, five place. So you have to move this decimal to the left hand side by five places. So what will you get? You will get 7.2 after moving decimal, right? And since you have moved this decimal by five places, what should be the power of 10? Then the power of 10 that you are going to have is 10 raised to the power 5. So this form that you got here of this particular number, that's a standard form, or you can say the scientific notation you have. And if you simplify this value, you are going to get exactly what has been provided here. Is it clear? Please go through these two examples first before I move to third example and the fourth example. Any doubt you guys have till now in both the examples that have been discussed? No doubt. All right. So check out example number 3 you have. So I'm taking case third. In case third, what is the number you have? The number we are provided is 00016. We all know whatever zeros are written before any numerical, before any non-zero values, they do not hold any meaning in this situation specifically. So 00016 is same as 16 or 16, right or not? So this 00016, it can be written as 16, and 16 can be written as 16.0, right? Now what we have to do here, we have to move this decimal in such a way there is all, so that there should be only one digit on the left hand side of decimal, rest of the digit should be on right hand side. So you need to move this by one place for this decimal to come here. So if you move it by one place, you are going to get 1.6, and because the decimal that was given to you, it has been moved by 1 point, so what will be the power of 10? The power of 10 that you are going to get is 1. And if you simplify 1.6 into 10 raised to the power 1, you will be getting the value which we are provided here, that is 00016. Like the exact same value is what you are going to get here. Understood? Please check this example number 3. Ask me if you have any query or any doubt in this. No doubt. Shall we move to example number 4? So we have case number 4 now. So in case 4, what is the number we have? This case is a bit different from the other cases, so be very attentive. We have 0.05. Okay. We have to write this number, which is 0.05, in the scientific notation or the standard form, you can say. Okay. And we know that what we do in standard form, while we write a standard form, we have to make sure that there should be only one digit on the left hand side of decimal. Rest of the digits must be on the right hand side of decimal, right? So but in all the three examples that we took before this, what we were doing is we were moving decimal by some places to the left hand side, right or not? If you talk about example 1, if you talk about example 2, or you talk about example 3, in all the three examples we were moving decimal, but we were moving that decimal by some places but on the left hand side. Here the situation is a bit different. Here you need to move that decimal by one position or maybe 2 point, but on the right hand side. And when we do that, what is that one thing which you need to keep in mind that I'm going to discuss? So here you need to move decimal by how many position? 1, 2, right? So you need to move it by 2 position on the right hand side. So this will become 5.0. And whenever you are moving the decimal by any place, let's say n number of places on the right hand side, then the power of 10 has to be negative. That means earlier, if you look at the first three examples, in the first three examples, the power of 10 that we considered, be it this example, be it this example, or be it this example, in all the three examples, you can see the power of 10 that we considered was positive. Here, the power of 10 that you need to consider must be negative, and that power will be equals to the number of places the decimal has been moved. Because the decimal has been moved by 2 places, therefore the power of 10 must be equal to 10 raised to the power minus 2. And if you simplify it, you will again get your original number, which is 0.05. Let me show that. You will have 5.0 into 10 raised to the power minus 2. Okay, so this can be written as 5 into 1 upon 100, because 10 raised to the power minus 2 is 1 upon 10 raised to the power 2, as per this rule of exponent, right? A raised to the power minus m is equal to 1 upon a raised to the power m. So if you use this rule of exponent, this is what you are going to get. So this is same as 5 over 100, and 5 over 100 is nothing but 0.05. So this value that we got here, it is exactly same to what we were provided in the problem. But this form that we have got after the simplification is the standard or the scientific form of the given number. I hope it's very clear to all of you. All the four examples, I hope you understood what is that one thing which you need to keep in mind while writing any number in the scientific form. You just need to keep one point. I would say 3 points in mind, not 1 point. The first point is there should be only one value on the left hand side of decimal number. Okay, rest of the value should be on right hand side of the decimal number. Okay, now you will come across two situations. One of the situation would be when you are moving decimal by some places on the left hand side. That would be the one situation. And the second situation would be when you are moving that decimal by some places on the right hand side. Okay, if you are moving that decimal by some places on the left hand side, then the power of 10 which you have to consider should be positive. And when you are moving that decimal by some places on the right hand side, then the power of 10 which you need to consider must be negative. Like these 3 points, if you know, if you have could come out over these 3 points, then you are done with it. Please go through all the four examples. Ask me if you have any doubt. I'm giving you 30 seconds. After that, we will do one problem. All right. Any doubt? Okay. So here we have a question. We have to write all the four examples in the scientific form. So this example we have 637.8. 637.8. So here we need to move decimal by one position, two position. Like we need to move decimal by two places to the left hand side. Okay. So this can be written as 6.378, and because the decimal has been moved by how many position, how many places, two places, so you will have 10 raised to the power 2 as the decimal moved by two places on the left hand side. Understood? In the second case, you have 0.0479. So you need to move decimal by one place, two place, three place. Okay. So what will you get if you move decimal by three places? You will be getting 47.9. And because the decimal has been moved by three places on the right hand side, the power of 10 which you need to consider should be negative. So you are going to have 10 raised to the power minus 3. Understood? That's a scientific form. Okay. After that, you have 7.86. So 7.86 is already in standard form. So you can write it like this: 7.86 into 10 raised to the power 0. That's like you don't need to do anything. In the last one, you have 12,378. So this 12,378 can be written as 12,378.0. And you need to move this decimal by 1, 2, 3, 4 positions. So if you move this decimal by 4 positions, you are going to get 1.2378. And because the decimal has been moved by 4 positions on the left hand side, the power of 10 which you need to consider must be positive. So you will be getting 10 raised to the power 4. So this is the standard form for the first case. This is the standard form for the second one. This is for the third one, and this is the standard form for the fourth one. So like we are done. You can go through all the four cases and you will see how easy it is. Ask me if you have any query, guys. Any query? Anyone? Shall we move ahead if you don't have any query, guys? All right. So you can see the first one is 6.378 into 10 raised to the power 2. That's exactly what we got here. The second one is 4.79 into 10 raised to the power minus 2. Sorry, 10 raised to the 3 second, first 1 minute, 4.79 into 10 raised to the power minus 2. Sorry, we moved it by 3 places here by mistake. It should be 4 point something. This should not be there and this should not be there. We wrote it 47. Ideally, it should be 4.79. That is correct. Okay. The third one is 7.86 into 10 raised to the power 0 because that was already in the standard form. Fourth one is 1.2378 into 10 raised to the power 4. So that's exactly what we got here. Is that clear? So this one is correct, this is correct, this is correct, this is correct. All four are correct. And I hope you all got how we do it. Right? So check out. Now, there are a few important things also which I would like to tell you. Whenever you are writing any number in scientific form or the standard way, then this value that you have here, this is referred to as coefficient. So in case you hear this term anywhere while reading exponents and powers, like they are talking about exponent, then it should be very, very clear to you which number are they talking about. They are talking about this very first number. This value which is written here as a power, this is called exponent. Okay, this is called exponent or power, and this value is called base. Okay, we already know these things. Okay, these are very minor things, but yeah, important as well. Okay, so now we have how we can represent large numbers in the standard form. All right, so what does it says? Any number can be expressed as a decimal number between 1 and 10. Listen very carefully what they are saying. They are saying you give me any number. Okay, then they are saying you can always write that number as a decimal number between 1 and 10. Okay, multiplied by a power of 10. Okay, so they are saying you give any number, you can always write it as a decimal number between 1 and 10 multiplied by power of 10. So that's the beauty of mathematics, we can do that. And this form of representation is called a standard form. This is exactly similar to what we did just now. So let us see what we have here. They have given three examples, guys. And before we take three examples, let us understand this figure we are provided here. We all know what is this symbol. This is a symbol of decimal point. We all are aware of that. Okay. We also know what is unit place, or what do we call unit digit, tens digit, hundredth digit, thousand digits, etc., etc. Okay. This value that you have, the first value on the left hand side of any decimal point is called unit digit. Is that clear? I repeat again, the very first value on the left hand side of a decimal number is called unit digit. The second value that you have on the left hand side of a decimal number is called tenth digit or tens digit. Okay, this one. And the very first value which you have on the right hand side of a decimal number is called 1/10. Okay, 1/10 of 1/10. Okay, the second one is called hundredth. All right, the third one is called thousandth. Okay, although we studied this in our junior session, but it was a quick revision of that thing. So here what we were discussing, guys, we were discussing if you have any number, how you can write that number as a decimal number between 1 and 100, which is multiplied by some power of 10, and that power of 10 could be positive, that power of 10 could be negative as well. All right, so what do we have? We have 500, like that's the first value we have. Okay, so 500 is already like there is nothing that you need to do here. You have 500, and 500 can be written as 5 into 100, right? 5 can always be written as 5.0 into 100 can be written as 10 raised to the power 2. So the number which was given to us initially, that was 500. We have written that particular number as 5 into 10 raised to the power 2. Is that clear? We have written that number as 5 into 10 raised to the power 2. So that value means the coefficient here is between 1 and 10, which you can see, and that has been multiplied by 2, like the power of 10, which is 2 in this particular problem. Like that's exactly what we need to do in every situation, guys. You have here 5, 6, 7. So 5, 6, 7 can always be like 5, 6, 7 is same as 567.0. So you need to move decimal by 2 positions on the left hand side. So this can be written as 5.67 into 10 raised to the power 2, because the movement of the decimal is on the left hand side by 2 places. Understood? Very easy. Then you have 56.78, guys. So 56.78, you need to move this decimal by 1 position on the left hand side. What will you get? You will be getting 5.678. And since the movement of the decimal has taken place by one place on the left hand side, so it will be multiplied to 10 raised to the power 1. Let me take one more example here. Let's say you have, let's say you have 0.0429, okay, and you want to write it in the standard form. So now the position is, now that this number is a bit different from the numbers that we choose or that we selected earlier. So here if I move, because I need to move, or I need to make sure that the decimal has, there should be only one digit on the left side of decimal and rest of the term should be on right side of decimal. So I need to move this decimal by how many places? One place and second place. So if I move it by 2 places, I'll be getting 4.29. And because the movement of decimal has been done by 2 places on the right hand side, so the power of 10 must be negative. That should be 10 raised to the power minus 2. So that's the standard form here. So this is very similar to what we did earlier as well. I hope it is very clear to all of you. Super easy topic. Please go through it and ask me if you have any query. Done. Anybody have any query in this? No query? Okay. So this is the problem we have. Like, this problem is based on the topic that we covered just now. What does it say? It says represent distance between Earth and Sun in exponential form, or the standard form. That's what they are saying. And for your help, because many kids might not be aware of what is the exact distance between Earth and Sun, they have given the distance between Earth and Sun, which is this value. Okay, very big value. So let me denote distance by d. Okay, let d be the distance, d be the distance between Earth and Sun. Earth and Sun. Okay. Then what do we have? We have the value of d. We have value of d. What is d? D is 149600000, right? This is the value we have. You have to write this in the standard form. Okay. So this value that you have, we can write it like this as well: 1496 12345 zeros. Okay, 12345.6. That's how we can write it. Now we need to write it in the standard form. So for that, you need to move this decimal one place, two place, three place, four place, five place, six place, seven place, eight place, nine place. Let us recheck. One place, two place, three place, four place, five place, six place, seven, eight, nine. So you need to move it by how many places? By 9 places. So if I move it by 9 places, what will I get? I will get 1.496. And because the movement of this decimal has taken place, like the decimal has been moved by 9 places on the left hand side, therefore the power of 10 which you have to consider is positive. So that is 1.496 into 10 raised to the power 9. That is the that's a standard way of representing the distance between the Earth and the Sun. Is that clear? Please check it. Right, done. Okay. You can check here as well. They have done the exact same thing. Uh, that is, this was the distance. And the standard form will be 1.496 into 10 raised to the power 9. That's exactly what we got as well, guys. I hope this topic is very clear to all of you. Now comes the topic how to compare the very big or very large number. Basically, how you can compare any two numbers. Okay. And here it is large and a small number. So I have taken an example to illustrate that to you. Okay. Listen to me very carefully when we discuss this example, and everything is going to be super clear to you. Okay. What have we provided? We are provided diameter of sun, which is 1.4 into 10 raised to the power 9 meter, and the diameter of earth, which is 1.2756 into 10 raised to the power 7 meter. Then they are saying compare the diameter of the sun with the diameter of earth. So we need to compare, and after, it's not only about comparison, you have to actually extract some result out of that, or you have to tell like what does that comparison tells us about the diameter or the sizes of the sun and the earth. So to compare it, what we did, we divided the diameter of sun. Okay, I'm going to denote it by ds. Okay, that's diameter of sun by the diameter of earth, which is de. So this ds denotes diameter of sun, and this de denotes diameter of earth. Okay, so we divided both the values. Okay, when you divided both the values, you got, because here you have 10 raised to the power 9 and here you have 10 raised to the power 7. We know that when 10 raised to the power 9 is divided by 10 raised to the power 7, because the base are exactly same, the powers are going to get subtracted. So you will have 10 raised to the power 9 minus 7, which is same as 10 raised to the power 2, and 10 raised to the power 2 is nothing but 100, and that's how we got this 100. We haven't done any changes in 1.4 and 1.2756. Those two things are exactly same. Okay, so this is what we got, and after you divide these two values, you will get the answer, which is approximately 100, like very close to 100. Okay, what does it says? It says that the diameter of the sun that you have, because ds is what we got here, we got ds upon de is equal to 100, right or not? Or can we say this or not, that ds is equal to what? Ds is equal to 100 times of de, right? So what does it says? It says that the diameter of sun is 100 times the diameter of earth. In other words, can we say that the sun is 100 times large than the size that we have of earth? That's exactly what it says. Correct or not? It says diameter of sun is 100 times the diameter of earth, which is same as the size of the sun is 100 times the size of the earth. That's a result we deduce. Now what is that one thing, like here we compare two values. Okay, and you observed how easy we compared them. So whenever you are comparing any two numbers, be it large or small, what is that one thing which you need to keep in mind? Okay, so very large number and very small number can be represented in the standard form or the scientific form. So what's your first step? You should go with the representing that particular number in the standard or the scientific form. कुछ भी value given है, your goal is to represent that number first in the standard or the scientific form. Okay, where m is a decimal number greater than or equal to 1, we all know that, but less than 100. And after representing those numbers which you have to compare in the standard form, you just divide them, and you will get to know like which value is bigger or which value is smaller and all. Is that very clear to everyone? What's the first step? The first step is you should convert the given numbers in the standard or the scientific form. After converting the given numbers in the standard or the scientific form, you should divide both the values. And when you divide both the values, you will easily get like which of the two values, which of the two values which are provided to you is bigger or which one is smaller. Understood? Please go through it and ask me if you have any doubt or query, guys. Understood? All right. This is an important topic. This is important. What does it says? Fractional powers means when the powers you have, they are fraction. Then how to go about it? Super easy again. Okay. So a fractional exponent is a technique for expressing powers and roots together. Uh, the general form of a fractional exponent is this. Okay, let us understand what they have written. They have written b raised to the power n by m, right? They have written b raised to the power n upon m. B raised to the power n upon m. Can we write this b raised to the power n upon m as b raised to the power n into 1 upon m? We can write that. True. And this can further be written as b raised to the power 1 upon m, that is whole raised to the power n. This is as per the rules of exponent. Correct or not? First, I wrote this power n by m as n multiplied to 1 by m, right? And after writing this power, which is n by m, what I did, I wrote it as n into 1 by m. After writing it in the form of n into 1 by m, I wrote it as b raised to the power 1 by m whole raised to the power m. And we can write that as per the rules of exponent. Okay. Now, what does it denotes? It denotes mth root of b. Like this is how we pronounce it. It denotes mth root of b. Okay. And mth root can, like, how do we represent a square root? We represent a square root like this, right? This is a square root of x, right? Square root of x. If I write 3 here, what will I say? I will say cube root of x, right? Cube root of x, right? If I write 4 here, I will say fourth root of x. Okay, fourth root of x. Similarly, if I am writing n here, that means I am talking about nth root of x. Clear? So since m is written, that is mth root of x, and it can be written as m nth root of b raised to the power n, and we can simplify it later on. First, you need to simplify the value which you have inside the bracket. After the simplification of that value, you have to solve this power which is given here. And that's exactly what they have written. A raised to the power 1 upon n is same as nth root of, or this a raised to the power 1 upon n is same as nth root of a, and a raised to the power n by n is same as a raised to the, or nth root of n raised to the power m, right? That's exactly same. We all know what is this. Like this is base, that 1 by 2 is power, right? This 1 is power, this 2 is root index. These are the general notation that we covered in the earlier as well. So please go through it. If you have any doubt or any query in this, please ask me, and I will tell you an application of this fractional power also in the next slide, and you will, like, it will become more clearer to you. Please go through it. Done? Is anybody having any doubt or any query in this yet? No query? Right. So they are asking us simplify using laws of exponent. Okay, so this is not very direct problem. So check what are we provided. A square root of 4 raised to the power minus 3 means what? That means you can say 1 upon square root of 4 raised to the power 3. Like we can say that, right or not? Because we know that a raised to the power minus m is same as 1 upon a raised to the power m. This we studied in rules of exponent. Okay. Now, what is the square root of 4? We all know square root of 4 is 2. So this will become 2. raised to the power 3, right? We all know that square root of 4 is 2. So we replace the square root of 4 by 2. And now we know what is 2 cube. 2 cube is 8. So you will be having 1 upon 8. That means the answer to this particular problem is 1 upon 8. See how easy it was. It's just that you have to simplify one step at a time. If you simplify or if you solve one step at a time, believe me, you will very easily get the answer to the problem that is given to you, or whatever problem has been provided to you, you will quite easily get the answer to that problem. Okay, it's about solving one step at a time. Understood? Okay, so you can see this solution has been given for your reference only. Let me explain this as well. You are provided square root of 4, which is same as 4 raised to the power 1 by 2 raised to the power minus 3. And this can be written as 4 raised to the power 1 by 2 into minus 3. We know that. So that will be 4 raised to the power minus 3 by 2, because a raised to the power m raised to the power n is same as a raised to the power mn. Okay. And when you move this term into the denominator, the power is going to become positive as per this rule, which is a raised to the power minus m is same as 1 upon a raised to the power m. So we got 1 upon 4 raised to the power 3 by 2, and 1 upon 4 raised to the power 3 by 2 will give you, like, it can be written as 4 cube, that is further raised to the power 1 by 2. 4 cube is 64. The square root of 64 we all know that is 8. So the answer is 1 by 8. You can either go with this approach or you can use the approach which I mentioned. Both the approaches to this problem are 100% correct. Done? All right. So now we have few questions which you have to try as homework, guys. These questions are like homework. You have to convert each of the number into the exponential form in the first and the second case. Then again, standard form. Third, you have to simplify using rules of exponent. The third is very similar to the problem that we did just now. You have to try these three problems as homework. In case you are not able to do these problems, you feel free to discuss with your Ask IITians expert, guys. He or she will be more than happy to help you out with that. Just make sure that you revise this topic once or twice. And believe me, if you'll revise it once or twice properly, you will get it, very easily get it. Okay. So what we discussed today, we discussed four topics. The first topic was primarily how to represent any number in the standard form. We did problems based on that. The second topic was how to compare the large and the small numbers. We discussed that also. Like, first you have to write number in the standard form, and after writing the number standard form, divide them, and you will get to know which number is smaller and which is bigger. The third was like fractional powers of exponent that you have, which is again like how you can simplify in case you come across the fractional power. What is the meaning of that? We did problem based on that as well. I hope this particular topic is very clear to everyone. So that is it from this session. Thank you so much for attending. Have a great day. See you all in the next session. Goodbye.